Good morning, Saurav ma'am. I am Arjun Rastogi, and today we are going to conduct experiment 2 for electronics and electronics circuit lab. In this experiment, we are going to construct a wheat-stone bridge by using resistor and capacitor to measure the node voltage and its output voltage. Materials and equipment which we are using are 4 resistors of 100 kilo ohm, 2 resistors of 1 kilo ohm, 1 capacitor, 2 resistors of 10 kilo ohm, a multimeter and a ADLM 1000 kit. Now I am going to construct a wheat-stone bridge while using 100 ohm resistors, approximately 100 ohm resistors. So for this we required a 400 ohm resistor. Here I have constructed a balanced wheat stone bridge by using a 100 kilo ohm resistor. Now we are going to power this circuit by using ADLM 1000 kit. Now let's we power the circuit. So the voltage across the VA node, which we have calculated by voltage divider rule, is 1.25 volt. Now we are going to calculate the voltage at node A by using our multimeter. Here we have power supplied the circuit. Because of the tolerance in the resistors, I have used the resistor with 10 to 15% tolerance. So it will vary between plus 10 ohm or minus 10 ohm resistors. Now I am going to calculate the resistance at node B. So here you can see that the voltage across the resistor voltage across node B is 1.16 volts. Now here you can see that the output voltage between node A and node B is 0 volt. This is because as you can know that output voltage is equals to difference between the voltage in nodes A and B. Now our next task is we have to repeat this experiment with E equals to 2.5 volts plus 1 sine omega t volts from the analog board. So for this we have to supply one AC volt which is 2.5 volt and one DC volt which is 1 sine omega t, and we have to calculate the same voltage difference between the node A and node B to find out the output voltage. So we are providing some AC and DC voltage, so the graph of the output voltage shifted upward with 2.5 volt with a sine wave. So if we need to find out maximum excitation voltage, which is 2.5 volt plus 1 volt equals to 3.5 volt, and minimum excitation voltage, which is 2.5 volt minus 1 volt is equal to 1.5 volt. So we need to find out this excitation, I have to short circuit node A and node B. Here I have short circuited the node A and node B. So here I have connected channel B to node A, ground, and channel A and ground between two nodes. So the output of this AC and DC circuit would lie between something around 1.75 volt and 0.75 volts. As you can see here, I have set the maximum excited voltage is 3.5 volts and minimum excited voltage is 1.5 volts. So the output voltage is between 0.75 to 1.75 volts for node A. Now see what will be the output at node B. Here I have connected channel B to node B. So theoretically it should be lie between 1.75 volt and 2.75 volt. So as you can see that the output voltage at node B lie between 0.75 volt and 1.75 volts. Now I have calculated the voltage difference between the A node and B node, which is approximately 0, which shows that this bridge is totally balanced Wheatstone bridge. Now our next task is that we have to build a balanced Wheatstone bridge with one 1k ohm resistor, 100k ohm resistor and two 10k ohm resistors. So here you can see that we have one 1k resistor, two 10k resistors and 100k resistor. And 100k resistor. Now let me construct a Wheatstone. So I have replaced this resistor with 1k ohm resistor, this resistor with 10k ohm resistor, and this is 100k ohm resistor. So here you can see that the voltage across node A is somewhere around 2.10 volts. Now the voltage between node B is somewhere around 2.19 or 2.20 volts. Now the output voltage between node A and node B is 0, which shows that this is a balanced Wheatstone bridge. Now our third task is that we have to add a 1 kilo ohm resistor between R1 and the node between. Now we have to calculate the voltage across node A, node B and the output voltage. Now the output voltage between node A so the voltage across node A is, as you can see, it is 2.23 volts. Now voltage across node B, is 2.17 volt. Now let me calculate the output voltage. As you can see, the output voltage is 0.03. It is little bit of variation because of the tolerance of the resistor. It represents the Wheatstone bridge is not balanced. We have not constructed a balanced Wheatstone bridge. Now it's time to remove the AC unwanted. So for that we have constructed a balanced Wheatstone bridge, and so that we have added a capacitor of microfarad between it. We have added a capacitor at output drain to filter the unwanted AC components. So here we have also done it as we have done it previously. We have added a channel B to node A, channel A, and 2.5 volts here and here. Here I have added 1.5 volt DC component and 1 volt excitation voltage, so it will become 2.5 volts, and the output voltage is between range of 0 to 1.25 volts, as you can see here. Now our next task is we have to replace a Wheatstone resistor in a single resistor, means Thevenin's resistor, and add a capacitor to it, so it will be a low pass filter which allow a low frequency and saturate out at high frequency. Let's take a look, try to measure the concept. So I will provide one sine omega t. I will provide AC and DC, which is same 2.5 volts plus one sine omega 2. Try to vary conquer frequency from 1 hertz to 1 kilohertz and take a look what is the output of the circuit. At we add frequency, it will saturate. I have noted down this data and just plot a graph.